We've got an equation, 4 sine squared theta minus 3 sine theta, 4 sine theta minus 3 sine theta minus 1 is 0. 4 sine theta minus 3 sine theta minus 1 is equal to 0. As I work with my students, one of the things that I tell them is that though this is a trigonometric equation, that their challenges are not in trigonometry. For the most part, I'm discovering that their challenges are in Algebra 1 ideas. By that, what I mean is I tell my students that if they're given this equation here, the only thing that makes this an Algebra 2 problem is the fact that you got the trigonometric function there. What I tell my students is to rewrite this to get rid of all confusion. So replace the sine with x. So what I ask my students to do is, instead of solving this problem, 4 sine squared, make that 4x squared. Instead of minus 3 sine x, I ask them to make that, or excuse me, minus 3 sine theta, I ask them to make that negative 3x. Minus 1 is 0. All right, so what I ask them to do is turn this problem into an algebraic problem. Now, if they can solve this second degree equation, this quadratic equation, they should be able to solve this trigonometric equation. What I'd ask my students to do is be able to factor that. You can't pull anything out. You can't pull anything out of 4, 3, and 1. So what I ask them to do is be able to factor that, 4x and x, and then you two numbers multiplied together to give you a negative 1, or minus 1, and plus 1. And if you check this, you get the outers are negative 4x, the inners are plus 1x, and you get the negative 3x that you desire. That means that this can be factored. Well, now you take your understanding of this Algebra 1 technique called factoring, and you apply that to this trigonometric equation over here. So what I'd like my students to be able to do is be able to see that this is factorable. All right, so what we have is we have 4, not 4x, but 4 sine theta. And not over here, you don't have x, you'll just have sine theta. And then two terms multiplied together give you a negative 1. You'd have plus 1, minus 1, just like you have over here. Plus 1, minus 1. All right, so you got 4x plus 1, but over here you have 4 sine theta plus 1. Hopefully you see the connection between this Algebra 1 problem and this Algebra 2 trigonometric equation. You set this equal to 0, and now you set this binomial equal to 0. You got 4 sine theta plus 1 is equal to 0. And over here you have sine theta minus 1. That's equal to 0. All right, so you set them both equal to 0. And you get 4 sine theta is equal to negative 1. 4 sine theta is equal to negative 1. And you divide by 4. Divide by 4. You get sine theta is equal to negative 1/4. All right. So now what you've got to do is you've got to be able to use your understanding of trigonometry to solve this. What I tell my students is that it's sort of somewhat of an acronym. I say all students take calculus. And I start, all students take calculus. I tell them that starting in the first quadrant, second quadrant, then third quadrant, fourth quadrant, to say all students take calculus, and that tells them what the sign of the trigonometric function is in the quadrant that they're working in. So everything is positive in the first quadrant. Students, which represents sine is positive in the second quadrant. all students take, tangent is positive in the third quadrant, and then calculus, cosine is what's positive in the fourth quadrant. So where is sine negative? Sine is negative in this quadrant and this quadrant. That's where sine is negative. Only thing that's positive here is tangent and cosine. All right, so then what you have to do is, because this is not a special triangle, you have to put the inverse sine of not negative 1/4, but 1/4. You've already dealt with the negative sign here. That's why you put the solutions in the third and fourth quadrant, because you've already dealt with that negative. That's where the sign is negative. So then, in your calculator, you put the inverse sine of 1/4. And I did that already before I got here on the show. And what you end up with is theta, I'll put it here, you end up theta being equal to 14.48. So that means that this angle here is 14.48. And so is this angle here. This angle here is 14.48. I put in the calculator already, making sure that the calculator was in the degree mode. Then, if you put your calculator in the radian mode, depending on what your teacher asks for, you would get the answer would be either 14.48 in the degree mode, or if you put your calculator in the radian mode, you get 0.252. You put 0.252 there, and then you put 0.252 here. All right. So your answers, your final answer for this part of your problem would be theta would be equal to, this would be 3.14 plus 0.252, which would give you 3.39. This 3.39 came from the fact you're dealing with pi, which is 3.14, and then you'd add the 0.252, you'd get 3.39. And then over here, your answer for theta, if you were in the degree mode, your answer would be 180 degrees. This would be 180 degrees plus the 14.48, and that would give you 194.48. All right, so once again, in radians, you would identify this measure, this degree measure, as 3.14, and you'd add 3.14 to the 0.252. That would give you 3.39. But if you're using degrees, you wouldn't call this pi radians. You'd call this 180 degrees. And because you're not at the answer, this is your answer here. You take 180 plus 14.48 to get 194. So this is the same way. Your first answer is either 3.39 or 194.48. This is the same answer written in two different ways. This is in degrees. This is in radians. Now this answer over here, you'd be looking, if you're using radians, this is 6.28 or 2 pi. This is 2 pi or 6.28. You'd take 6.28 and then you go back 0.252 and you get your answer to be, I did this before we got here, you'd get 6.03. 6.03. And if you're in degrees, you would take, this is 360 degrees, but you'd go back, this is your answer here, 14.48, and you'd get the answer 345.52. All right? So that's only part of your answer. We've only have two answers listed. I've listed the answer both in radians up top, and then I've listed the answer in degrees on the bottom. And you would decide which route to go depending on the directions of the problem. All right? So over here you've got a second part of your problem. This is going to yield an answer 2. You add 1 on both sides, you get sine of theta is 1. Now here, interestingly enough, what you're going to discover is I ask my students not to need a calculator, not to require a calculator on this particular problem here. What I'd ask my students to do is draw the sine curve the sine of what angle is 1, my students would have to be able to draw a quick version of the sine curve. Let's call that pi over 2, pi, 3 pi over 2, and 2 pi. That's 1, that's negative 1. And the standard sine curve would look something like this. This is the sine curve. All right. So the sine of which of these angles, is 1. Well, hopefully you can see that the sine of this angle is 1. So the answer that you would have here would be the result of pi over 2. That's where sine is 1. Now, in degrees, another way to say pi over 2 is 90 degrees. All right, so what you're looking at is 3 different answers to this one equation. 3 different answers. One answer would be, and by the way, the decimal equivalent to this would be 1.57. All right, so this is just like any other equation. What value of theta do you have to put in here and here and then subtract 1 to get 0? Well, these are the answers. 3.39 radians, 6.03 radians, and 1.57. These 3 answers in radians, and these 3 answers in degrees. All right, so here's another problem. Here is another problem. So we got 2 cosine squared theta is equal to cosine theta. My students, unfortunately, were having some challenges solving this problem. Let me make it a little bit neater. 2 cosine squared theta is equal to cosine theta. All right, so they had some challenges with that. But again, as I stated earlier in the show, if you get the slightest bit confused with this, get rid of the source of confusion. Get rid of that cosine. So instead of 2 cosine squared, make that 2x squared is equal to, instead of cosine theta, let's just make that x. So wherever you see cosine theta, you're making it x. So now you got 2x squared, 2 cosine squared is equal to cosine theta. So now you should be able to solve this equation. And your ability to solve this equation here would give you direction on what to do with the more demanding trigonometric equation. All right? So if you cannot solve this equation right here, you need to go back to your algebra. Quickly, what I would do here, subtract the x on both sides. You get 2x squared minus x is 0. You've got to be able to solve this equation. Now you factor out the x. You get 2x minus 1 is 0. All right? So that gives you direction on what to do over here. All right? So first step would be to subtract cosine theta on both sides. And you end up with 2 cosine squared theta minus cosine theta is 0. All right? So now you factor out the cosine theta. Cosine theta times, you end up with 2 cosine theta minus 1 is 0. And now you set this equal to 0. You set cosine theta. That's equal to 0. You also set 2 cosine theta minus 1. You set that equal to 0. And now you just solve using your understanding of trigonometry. You've got to solve this using your understanding of trigonometry. Similar to what we did here, where we drew that sine curve to get a solution, I would ask my students to be able to do the same thing here. A quick cosine graph, and I ask my students to know what these graphs look like on their own. I don't provide them for them. All right, so make that pi over 2, pi, 3 pi over 2, 2 pi. This is 1, this is negative 1. By the way, this is 90 degrees. This is 180 degrees. Another way to say pi radians is 180 degrees. Another way to say 3 pi over 2 is 270 degrees. Another way to say 2 pi is 360 degrees. You're saying the same degree measure in 2 different ways. Now, the cosine curve looks something like this. Cosine curve looks something like this. And now you answer the question, the cosine of what angle is 0? Well, hopefully you can see that the cosine of pi over 2 and 3 pi over 2 is equal to 0. So your answers for this particular part of your problem would come from the cosine curve. So theta would be equal to pi over 2. Theta would also be equal to 3 pi over 2. All right, so those are your answers. All right. The way you'd write these same answers in degrees would be 90 degrees and 270 degrees. I don't want you to think, I don't want you to think that I've got 4 different answers here. What I have is I have 2 different answers, and each of these answers are written in 2 different ways. Another way to say pi over 2 radians is 90 degrees. Another way to say 3 pi over 2 radians is 270 degrees. All right, so now let's handle another part of our problem where we're going to add 1 to both sides. You end up with 2 cosine theta is 1. You divide by 2 on both sides. You get cosine theta is equal to half. And now you got to understand more trigonometry without a calculator. This entire problem I'd ask my students to do without a calculator. All right, so here you'd have to recognize 1 to 2 ratio. 1 to 2 ratio. You'd have to recognize that that could possibly be a special triangle. Acknowledge a theta. You could either acknowledge theta being here or here. That would have to be 90 degrees there. Well, the adjacent is 1. Cosine by definition means the adjacent over hypotenuse. The adjacent is 1. The hypotenuse is 2. And you'd have to recognize that this is a 60-degree angle or a reference angle of pi over 3. All right, so you'd have to recognize that this would be radical 3. Your reference angle would be 60 degrees. All right, so other answers to this problem would be wherever the cosine is a positive half. You have to set up your coordinate axis. Cosine is positive. Cosine is positive in the first quadrant. Remember, all students take calculus. Cosine is positive in the first and fourth quadrant, and the reference angle would be pi over 3, or 60 degrees. It'd be pi over 3 there, pi over 3 there. So your answer would be, in addition to pi over 2 and 3 pi over 2, your answer would also be theta is pi over 3. It's pi over 3, and this is 6 pi over 3. Another way to say 2 pi is 6 pi over 3. Go back pi over 3 to get 5 pi over 3. So your answers would be these 2 and these 2. Another way to say pi over 3 in degrees, another way to say pi over 3 and 5 pi over 3 in degrees would be 60 degrees and 300 degrees. All right, so 4 answers. There would be 4 answers to that problem.